Scholars, let's look at TEK 4.3b, which is a continuation from TEK 4.8b. So I really recommend you watch that video first before you watch this one, because in this one I'm going to be quickly going over that video and moving on. So I strongly recommend you watch that video first. So it says, I can decompose a fraction. Decompose means break down in more than one way into a sum of fractions with the same denominator using concrete and pictorial models and recording results with symbolic representations. So in my last video, I would always say show 14/8 as a sum of fractions, and so you would show it that way. But in this video, I'm going to start using the word decompose 14/8 into unit fractions. So here is 14/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8. And I'm sorry that I don't have all the pieces the same. Just pretend that they're the same. I forgot to get a second pack of the same kind. So I would represent 14/8 like this. So here's what 14/8 would look like. And so now what we're going to do is we're going to also put it in mixed number form. So when you look at my 14/8, 8/8 equal 1 whole. So I have 1 whole and 1, 2, 3, 4, 5, 6 eighths extra, like left over. So to represent that, it would be 1 whole and 6 eighths. 1, 2, 3, 4, 5, 6, 7, 8 right here. 8 eighths is, that I just circled, is this right here, these 8 eighths. And then 1, 2, 3, 4, 5, 6 is these 6 eighths right here. That's what this is. So this is taking the unit fractions and putting it in the improper fraction where A is greater than B and putting it into mixed number. This part here is using symbolic representations, and these could be pictorial models. These could also be drawn on paper for you. Here are two other ways to show 14/8. There's actually many ways, but here's just two other ways. 8 eighths plus 6 eighths, 2 eighths plus 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 2 eighths. Because the TEK says you can decompose a fraction in more than one way into a sum of fractions with the same denominator. So, you know, I'm showing them all broken into eighths. Let's look at another example. So hopefully since you watched the last video on 4.3a, you should know how to do this. So go ahead and decompose 18/10 into unit fractions and see if you can put it in mixed number and write it one other way, showing a sum. So here are 3 different ways you can show 18/10 broken up. Remember, there's more than just these 3 ways. This is broken up in unit fractions. This one will help you put this in mixed number, and then this one I just picked from random. So here is 18/10 in separate pieces, and so as you can see, 10/10 equal 1 whole, and then I have 8/10 left over. So that's why this is really nice, because that 10/10 shows you that there's 1 whole and then 8/10 left over. And you can look at this and be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and circle that. And then 1, 2, 3, 4, 5, 6, 7, 8 left over. So this is just a review from the last video. I'm going to move on and now show you, well, you're going to do some few practice problems real quick, and then I'm going to show you how to take this and convert it back to unit fractions. Here are 4 more that I want you to do. I want you to put them. Here are the answers. So I just wanted to show a little shortcut. If you are really catching on and understanding this, here is a faster way. So basically you count how many times does 5 go into 13. So 5, 10. So 2 times. 13 minus 10 equals 3, which means there are 3 left over. So then you keep the bottom number the same. So another example. 8 goes into 12 1 time. There will be 4 left over. So that's the top number, and then 8 is at the bottom. 3 goes into 11 3 times. 2 left over, so 2/3. 10 goes into 20 2 times, 4 left over, so 4/10. I hope you have a better understanding of sum of fractions to represent. Watch the next video, 4.3b, where now we're going to take this and break it into this. Okay, so now we're going to look at a mixed number, decompose 1 4/5 into unit fractions. So first of all, you want to get a visual of what's exactly going on. So I'm going to show you how to draw the visual, but I'm also going to have my math manipulative so you can see what's going on. So when you have 1 whole and 4/5, it's like saying I have 1 whole, and then I have this that's in fifths, and I have 4/5 of them. Okay, now you also want to understand that this is also in fifths. So 1, 2, 3, 4, 5. 5/5 and 4/5. 1 whole and 4/5. So you can also then break this up to 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5. This represents the 1 whole, and then 1/5 plus 1/5 plus 1/5 plus 1/5, which will equal this 4/5. So even looking at the picture, 1, 2, 3, 4, 5, 6, 7, 8, 9 fifths total equal 1 4/5. Let me get my math manipulatives out so you can see what I'm talking about. So here's one whole, okay? It was 1 whole and 4/5. 1, 2, 3, 4/5 right there. So we want to put this in unit fractions. So what we don't see is that this, you're looking at this as 1 whole and 4/5. You need to know that that 1 whole is cut into fifths. So actually, this is what you're seeing, 1 whole and 4/5. You need to think of that 1 whole in fifths. So 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5, 8/5, 9/5. So that's why this right here represents this. This is 9/5. 5/5 are 1 whole. The other 4/5 are the extra. Okay, so let's look at another example. 1 5/6 in unit fractions. So let's just look at pieces. 1 whole and 1, 2, 3, 4, 5, and then obviously this little piece here would have been the 6th one, but we have 1 5/6. So this 1 whole is also going to be cut into sixths. 1 whole is 6/6. So now you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sixths. So what I always tell my students is, you need to think of it like this. If you think of pictures, you have your sixths, 1 whole, and then you have, and then you have your sixths, okay? So 1, 2, this whole thing is colored in because it's 1 whole, and then this one is just 5 of it. So 1 whole and 5/6. Well, this is also called 6/6 plus 5/6, so that equals 11/6. Now, what can be annoying and frustrating is drawing those pictures, so here's a shortcut. I know there's 1 whole, okay, and then 5/6 in this one. So 1 whole would be 6/6. So 6/6 plus 5/6 equals 11/6, which is also 1 5/6. I want you to see if you can represent 1 7/12 in unit fractions. See if you can figure it out. So here is a visual. Here's 1 whole and then 7/12. So remember that 1 whole, imagine it cut into 12s because these are cut into 12s. So that's like saying 12/12. So 12/12 plus 7/12 equals 19/12. So I want you to understand that this is a strategy to take mixed number and put it into unit or sum of fractions. So what did I say? Oh yeah, 12 twelfths plus 7 twelfths equals 19 twelfths. 19 twelfths is equal to 1 and 7 twelfths. So, you can write 1/12 plus 1/12 plus 1/12, 19 times. But I'm just showing you that this is your one whole, and then that's your extra. So here's another way to think of it. You can write 12 twelfths and be like, just pretend that's cut into 12 pieces. And then be like, and then I had 7 twelfths in the second piece of pie or whatever you want to think of it as. So what I did was at the bottom, I wrote it 19 times and just wanted you to see that, we know 12 twelfths equals one whole. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you would take that and consider that one whole. And then 1, 2, 3, 4, 5, 6, 7, all of that is this extra here. I want you to see the two connected together. This is this whole thing, 12 twelfths and 7 twelfths, 12 twelfths and 7 twelfths right here. You need to see it broken up in different ways. I wanted to show you the shortcut that I explained earlier in the video, that you can, if you're given this and you're expected to change it to mixed number, a lot of you are going to write 1/12 plus 1/12 19 times, or you're going to do 12 twelfths and then, figure out that the 7 twelfths is the extra. So what you do is you decide 12 goes into 19 how many times? 12 goes into 19 one time with 7 left over, and you keep it in twelfths. So you just converted this to mixed number. Or let's say I'm given the mixed number and I'm expected to put it in improper fraction. So you would do 12 times 1 is 12, add the top piece which equals 19, and you keep the denominator, so 19 twelfths. So this is a great strategy to help you. So when you have mixed number, you want to go in a circle. When you have improper fraction, you just go up. 12 goes into 19, 12 times 1 plus 7. So I want you to try this one, decompose 3 1/3 in unit fractions. I am aware that, that this is more than 1, and so it's the same strategy. See if you can do it. Okay, so think of 3 whole and then 1/3 on the side. So each whole is going to have 3/3. So 3/3 plus 3/3 plus 3/3 plus 1/3 equals 3 1/3. Now you also need to remember that, we want unit fractions. So it's 1/3 plus 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 1/3 equals 3 1/3, or 11 thirds, like that. No, sorry, 10 thirds. Tries this next one. Press pause and then press play when you're ready. Okay, so I have 4 whole, and these are cut into fifths. 5/5 equal a whole, and then I have these 2/5 left over in that last piece. So 5/5 plus 5 plus 5 5/5 plus 5/5 plus 5/5 plus 5/5 equals 20/5, plus my 2/5 equals 22/5. So 4 2/5 is 22/5. The shortcut would be 5 times 4 equals 20 plus 2 equals 22. Let me explain why this shortcut makes sense. When I was doing this 5, 5, 5, 5, it's 4 groups of 5. So that's why you do 5 times 4. And then you have the 2 extra. That's why you do plus 2. So that's how you get 22/5. Okay, decompose 2 5/8, or show me the sum of unit fractions. Okay, so 2 whole, and they're broken up into 8s, so I know it's going to be 8/8, and then this last one here is going to have 5/8. So 8/8 plus 8/8 equals 16/8, and then plus 5/8, 16, 17, 18, 19, 20, 21, 21/8.